September 23rd, 1969, 10:15 hours. Everett, Washington, 37 kilometers north of Seattle. Yuri Mikhailovich Petrov stood at the entrance to the largest building he had ever seen in his life, staring up at a structure so immense that his brain struggled to process the scale. The Boeing Everett factory stretched before him like a steel cathedral, its doors tall enough to accommodate a 12-story building passing through them. The statistics he had been given during the briefing that morning seemed impossible. The building enclosed 472 million cubic feet of space. It covered 98 acres under a single roof. Inside this one structure, Boeing was manufacturing the 747, the largest commercial aircraft ever built, and they were doing it at a pace that made Soviet aviation production look like a cottage industry. Petrov was deputy chief engineer at the Tupolev Design Bureau in Moscow, responsible for overseeing production of the Tu-154, the Soviet Union's answer to Western tri-jet airliners like the Boeing 727. He had been designing and building aircraft for 23 years, starting his career during the Great Patriotic War when Soviet factories churned out fighters and bombers in desperate quantities to stop the Nazi advance. He had believed, as all good Soviet engineers believed, that socialist industrial organization was superior to capitalist methods. Central planning eliminated waste, coordinated resources efficiently, directed labor toward collective goals rather than individual profit. The propaganda had been so consistent, so pervasive, that Petrov had never seriously questioned it. That was before he saw what Boeing had built in Everett. The delegation consisted of 12 Soviet aviation specialists, officially invited by the U.S. State Department as part of a technology exchange program. It was 1969, and détente was beginning to thaw Cold War tensions just slightly. The Americans wanted to demonstrate their industrial capabilities, to show the Soviets what they were competing against, perhaps to intimidate them with the sheer scale of Western manufacturing prowess. The invitation had been extended to visit Boeing, McDonnell Douglas, and Lockheed facilities to observe commercial aircraft production. Petrov suspected the Americans had another motive as well. They knew the Soviets would attempt industrial espionage during these visits. Every member of the delegation had been carefully screened by the KGB before departure, and Petrov knew that at least 3 of his colleagues were intelligence officers whose engineering credentials were largely fabricated. The Americans knew this too. They were allowing the visit anyway, confident that what the Soviets would see would be simultaneously impressive and impossible to replicate. That confidence, Petrov was beginning to understand, was entirely justified. Their Boeing guide, a cheerful engineer named Richard Patterson, who seemed genuinely proud of what his company had accomplished, led them through the security checkpoint and into the main assembly building. The doors opened and Petrov stopped walking. Behind him, he heard Anatoly Sokolov, chief metallurgist from the Ministry of Aviation Industry, whisper something that sounded like a prayer. The interior of the building was a landscape of organized industrial chaos on a scale that seemed to belong in a science fiction novel. 6 747 aircraft in various stages of assembly occupied the main floor, positioned in a precise line that stretched into the distance. Overhead cranes moved with smooth precision, lowering massive fuselage sections into place. Hundreds of workers swarmed over each aircraft like ants on a hill, but there was nothing random about their movements. Every person had a specific task, specific tools, specific schedules. The coordination was balletic despite the immense scale. "Gentlemen, welcome to the 747 assembly line," Patterson said, his voice carrying pride that he made no attempt to conceal. "What you're seeing right now represents approximately 18 months of work distributed across 6 aircraft in different production stages. The plane closest to us, that's final assembly. She'll be rolled out for flight testing in 3 weeks. The one at the far end, that's just beginning major assembly. We bring them through the building in sequence station by station, each one receiving specific work at each position." Petrov moved closer to the nearest aircraft, craning his neck to take in the immense tail section rising above him. The 747 was massive beyond anything he had imagined from the technical specifications. Nearly 70 meters long, with a wingspan of 60 meters, standing 6 stories tall. It weighed 178 tons empty and could carry up to 370 tons fully loaded. The specifications had seemed exaggerated when he read them in Moscow. Standing beneath the actual aircraft, he realized they had understated the reality. "How many workers are assigned to each aircraft?" Petrov asked, his English heavily accented but functional. "Approximately 15,000 workers are involved in the complete production cycle," Patterson replied. "But that includes subcontractors, parts suppliers, engineers, quality control personnel, administration. On the assembly floor at any given time, you'll see about 1,200 workers actively engaged on the 6 aircraft currently in the building. 15,000 workers." Petrov mentally compared that to Tupolev's workforce. The entire Tupolev Design Bureau employed approximately 45,000 people total, and they produced multiple aircraft types, not just one model. Boeing was dedicating a third of Tupolev's entire workforce to a single aircraft program, and that was just the 747. Boeing also produced the 707, the 727, the 737. Their total workforce exceeded 140,000 people, and their production capacity dwarfed anything in the Soviet aviation industry. The 747 program represents an investment of approximately $1 billion, Patterson continued, leading them along a walkway that provided an elevated view of the assembly floor. That includes development costs, facility construction, tooling, initial production units. It's the largest private industrial investment in American history. We started design work in 1965, broke ground on this building in 1966, rolled out the first prototype in September 1968. First commercial delivery will be to Pan American next year. 4 years from design start to commercial delivery. Petrov knew that Soviet aircraft programs typically required 8 to 10 years from initial design to production delivery, and that was when everything went smoothly, which it rarely did. The Americans were moving at twice the speed, producing aircraft twice the size with capabilities that exceeded Soviet equivalents by substantial margins. "What is your projected production rate?" asked Colonel Grigory Volkov, one of the KGB officers disguised as an avionics specialist. Patterson smiled. "We're ramping up to 2 aircraft per month initially. By 1971, we expect to reach 3 per month. Our facility can potentially support production of 5 747s per month if market demand justifies it." The number seemed absurd. The Soviet aviation industry produced approximately 800 civil aircraft per year total, including small regional aircraft, medium-range jets, and long-range airliners. Boeing was talking about producing 36 of the world's largest airliners annually from this single facility, in addition to their other aircraft programs. And the Americans had multiple aircraft manufacturers. McDonnell Douglas was producing the DC-10. Lockheed was developing the L-1011. The combined Western production capacity for large commercial aircraft was perhaps 10 times greater than Soviet capacity. They moved through the assembly stations, and Patterson explained each stage of the process with obvious pride. The fuselage sections arrived from subcontractors already partially assembled, complete with windows, doors, interior frames. The wings came from Boeing's plant in Renton, massive structures that required specialized transport. The engines, Pratt & Whitney JT9Ds developing 43,500 pounds of thrust each, were installed at a station near the end of the assembly line. Every component fit together with precision measured in millimeters, despite the enormous size of the aircraft. "Quality control is absolutely critical," Patterson explained, stopping at a station where inspectors were examining wing attachment points. "Every rivet, every weld, every bolt is inspected. We use X-ray equipment to verify structural integrity at critical points. We pressure test the fuselage. We run complete system checks on all electrical, hydraulic, and pneumatic systems before the aircraft ever leaves this building. Our reject rate for major components is less than 2%, and any rejected component is analyzed to determine the cause of failure and prevent recurrence. Less than 2% reject rate. Petrov knew that Soviet aircraft production struggled with reject rates sometimes exceeding 20% for complex components. Quality control in Soviet factories was inconsistent at best, with political pressure to meet production quotas often overriding technical standards. Aircraft that should have been rejected for structural defects or system failures were sometimes approved anyway to avoid falling short of planned targets. The result was aircraft that required extensive maintenance, suffered frequent mechanical failures, and had safety records that did not compare favorably to Western equivalents. They spent 4 hours touring the facility, and with each passing hour, Petrov felt his confidence in Soviet industrial capabilities eroding like sand before a tide. The scale was impressive, but scale alone was not what disturbed him. The Soviet Union could build large factories if necessary. What disturbed him was the efficiency, the precision, the systematic organization of every aspect of production. Boeing's supply chain was a marvel of coordination. Over 1,500 suppliers provided components for the 747, spread across dozens of countries. Every component arrived on schedule, inspected to exact specifications, ready for installation. The logistics of managing this complexity would have overwhelmed Soviet planners, but Boeing accomplished it with computer systems that tracked every part, every delivery, every stage of assembly. They had invested millions in automation and information technology that allowed them to coordinate activities across thousands of workers and hundreds of companies. Soviet factories operated on different principles. Central planning determined production targets years in advance, regardless of actual demand or resource availability. Supplies arrived irregularly, forcing production lines to halt while workers waited for critical components. Quality varied wildly depending on which factory produced a part and which shift was working when it was made. The entire system lurched from crisis to crisis, with each emergency requiring intervention from party officials who knew nothing about engineering but had the authority to override technical decisions. At 14:45 hours, Patterson led them to a conference room overlooking the assembly floor. Through the glass walls, they could see the 6 747s arrayed like monuments to American industrial capability. Coffee and pastries were served, an attempt at hospitality that felt surreal given what they had just witnessed. "Gentlemen, I hope you found the tour informative," Patterson said. "Boeing is committed to advancing aviation technology, and we believe international cooperation can benefit everyone. Do you have questions about what you've seen?" The delegation sat in silence for a moment. Petrov glanced at his colleagues and saw the same expression on every face, a mixture of awe and dismay that no one wanted to acknowledge openly. Finally, Sokolov spoke, his voice carefully neutral. "Your production methods are very impressive, Mr. Patterson. Tell me, how do you coordinate such complex supply chains without central planning authority?" Patterson seemed genuinely puzzled by the question. "We have planning departments, of course, but coordination happens primarily through contracts and market mechanisms. Each supplier knows exactly what we need, when we need it, and what quality standards must be met. If they fail to deliver, we find other suppliers. The competitive pressure ensures efficiency and quality." "And what if a supplier fails?" Sokolov pressed. "What if they cannot meet production schedules?" "Then we have backup suppliers," Patterson replied. "For critical components, we typically have at least two sources. Competition between suppliers drives innovation and keeps costs down. It's one of the advantages of the American system. No single point of failure. No central bottleneck." Petrov understood immediately what Patterson was not saying. The Soviet system was nothing but bottlenecks. Every major component came from a single state-owned factory that had no competition, no incentive to improve, no alternative if it failed to perform. If the factory producing landing gear fell behind schedule, the entire aircraft production line stopped. There was no backup supplier, no market competition to drive efficiency, no mechanism to remove incompetent managers who could not meet technical requirements. "What about innovation?" Volkov asked. How do you ensure technological advancement when you rely on private companies motivated by profit? Patterson smiled again, that same pride Petrov had noticed earlier. Profit motive drives innovation, Colonel. Boeing invested $1 billion in the 747 because we believe it will generate even greater returns. Every airline wants more efficient aircraft, greater range, lower operating costs. If we don't innovate, our competitors will. McDonnell Douglas, Lockheed, European manufacturers, they're all trying to capture market share. The only way to survive is to build better aircraft than the competition. It was such a simple answer, so obvious once stated, yet it described a dynamic completely absent from Soviet industry. The Tupolev Design Bureau had no competition. They received funding from the state regardless of whether their aircraft met performance requirements or delivery schedules. Innovation happened slowly, if at all, driven by individual engineers' dedication rather than systemic pressure to improve. And when aircraft programs failed, as many did, the consequences fell on engineers and factory workers who were blamed for not meeting impossible targets set by planners who understood nothing about aviation. The tour concluded at 1600 hours and the delegation was transported to their hotel in Seattle. That evening, they gathered in Volkov's suite for the debriefing that everyone knew was coming. The KGB colonel sat at the head of the table, his expression carefully controlled, giving nothing away. But Petrov could read the tension in his posture. Volkov had seen exactly what they all saw, and he was trying to determine how to report it without appearing defeatist. Comrades, we must compile a comprehensive report on what we observed today, Volkov began. Moscow will expect detailed technical specifications, production methods, organizational structures, but we must also provide context and analysis. What are your initial assessments? Silence. Nobody wanted to speak first, to be the one who stated the obvious conclusion that every person in the room had already reached. Finally, Petrov decided that professional honesty was more important than political caution. Comrade Colonel, I believe we are not competing in the same league as the Americans in commercial aviation. What we saw today demonstrates an industrial capability that is perhaps 10 to 15 years ahead of Soviet production. The scale, the efficiency, the quality control, the supply chain management, these are not areas where we can achieve parity through incremental improvements. We would need fundamental restructuring of our entire aviation industry to approach what Boeing has accomplished. Volkov's eyes narrowed. That is a very serious assessment, Comrade Petrov. Are you suggesting that Soviet aviation industry is inferior to capitalist production? Petrov met his gaze steadily. I am stating an observable fact, Comrade Colonel. Boeing produces aircraft of greater capability, at higher volumes, with better quality control than we achieve. I saw their production line. I spoke with their engineers. Unless you believe everything we were shown was an elaborate deception, which I do not, then we must acknowledge that they have significant advantages in organization and technology. Sokolov spoke up, his voice thoughtful rather than defensive. I reached similar conclusions. The Americans have invested enormous capital in automation and quality control. Their workers use tools and equipment that we simply do not possess, and their supply chain coordination suggests information management systems far more sophisticated than what we use in Soviet industry. But surely they showed us only what they wanted us to see, protested Ivan Rostov, another engineer from the Ilyushin Design Bureau. This could be their most advanced facility, not representative of American industry as a whole. I considered that possibility, Petrov replied, but Patterson mentioned that Boeing operates multiple facilities, that other American manufacturers have comparable capabilities, that the entire Western aviation industry operates on similar principles. If this is simply one exceptional facility, why would they tell us about all the others? No, comrades, I believe what we saw is representative of standard American industrial practice, at least in their aviation sector. The discussion continued for another 2 hours, each engineer contributing observations, raising questions, trying to find some explanation that did not require admitting Soviet inferiority. But every analysis led to the same conclusion. The Americans had built an aviation industry that operated on fundamentally different principles from Soviet production, and those principles generated results that central planning could not match. The delegation spent the next 2 weeks visiting other aerospace facilities. At McDonnell Douglas in Long Beach, California, they observed DC-10 production. At Lockheed in Burbank, they saw work on the L-1011 TriStar. Every facility told the same story: advanced automation, sophisticated quality control, efficient supply chain management, high production volumes, superior product quality. The pattern was consistent and undeniable. They also visited parts suppliers, engine manufacturers, and avionics companies. They toured Pratt& Whitney's facility in Connecticut, where they watched production of jet engines with performance specifications that exceeded Soviet equivalents by 30%. They visited IBM's semiconductor fabrication facility, where they learned that the Americans were integrating computer systems into aircraft flight controls, something Soviet designers had barely begun to explore. Each visit reinforced the same fundamental reality. The technology gap was real, it was substantial, and it was growing. On October 8, 1969, the delegation returned to Moscow. Petrov spent the flight writing his report, trying to find language that conveyed the truth without sounding disloyal or defeatist. It was a delicate balance. He needed to inform Soviet leadership about what he had observed, but he also knew that unwelcome truths were often punished regardless of their accuracy. His final report ran to 63 pages, dense with technical details, production statistics, organizational analysis, and strategic assessment. The conclusion was carefully worded but unambiguous. The United States possessed overwhelming advantages in commercial aviation manufacturing. Soviet production could not match American volumes, quality, or efficiency using current methods. Closing the gap would require fundamental changes to industrial organization, massive investment in automation and quality control, and probably some adoption of market mechanisms to drive innovation and efficiency. The report was classified top secret and distributed to senior officials in the Ministry of Aviation Industry, the State Planning Committee, and the Central Committee of the Communist Party. Petrov never learned what response it generated, if any. He was not reprimanded or punished, but he was not promoted either. His career continued on the same trajectory, designing aircraft for a system that he now understood was inherently disadvantaged in global competition. But the report did not disappear entirely. Years later, after the Soviet Union collapsed and archives were open to researchers, historians discovered Petrov's assessment among thousands of similar intelligence reports. They found that Soviet leaders had known about the technology gap, had received accurate information from engineers and intelligence officers, had understood the structural problems with central planning. And they had done essentially nothing in response. Why? Because fixing the problems would require admitting that the fundamental premises of the Soviet system were wrong. Market competition worked better than central planning for driving innovation in complex industries. Profit motive was more effective than political direction for ensuring quality and efficiency. Private companies made better decisions about resource allocation than state planners who answered to party ideology rather than market reality. These were truths that Soviet leadership could not acknowledge without undermining the entire basis of their political authority. So the reports were filed, classified, and effectively ignored. Soviet aviation continued producing aircraft using methods that fell steadily further behind Western competitors. The Tu-154 that Petrov had worked on for years was a capable aircraft by mid-1970s standards, but it consumed 30% more fuel per passenger mile than competing Boeing and McDonnell Douglas models. The Il-86, the Soviet Union's answer to the 747, did not enter service until 1980, 11 years after the 747's first commercial flight, and it carried fewer passengers over shorter ranges while burning more fuel. Soviet airlines purchased these aircraft because they had no alternative, not because they were competitive with Western models. The technology gap that Petrov documented in 1969 only grew wider over the next 2 decades. By the late 1980s, Western aircraft manufacturers were producing computer-controlled fly-by-wire systems, composite materials that reduced weight and fuel consumption, high-bypass turbofan engines with unprecedented efficiency. Soviet designers struggled to implement technologies that the West had mastered a decade earlier, always copying, always behind, always constrained by an industrial system that could not match the pace of Western innovation. Petrov retired from Tupolev in 1987, 2 years before the Berlin Wall fell and 4 years before the Soviet Union collapsed entirely. In 1994, a Russian aviation magazine interviewed him about his long career, and the interviewer asked about his visit to Boeing in 1969. The question had clearly been waiting for years. "I knew the Cold War was over the moment I walked into that building in Everett," Petrov said quietly. Not over in the sense that political tensions had ended, because they had not, but over in the sense that the competition's outcome was determined. The Americans had built an industrial system that we could not match. They were not just ahead in technology, they were ahead in the fundamental methods of innovation and production. We could steal their designs, copy their aircraft, but we could not replicate the system that generated continuous improvement. "Did you report this to Soviet leadership?" the interviewer asked. "Of course, I wrote a comprehensive report. So did others on the delegation. We documented everything we saw, analyzed the implications, recommended responses. The reports went to the highest levels of government." And what happened? Petrov gave a bitter smile. Nothing happened. The party could not admit that the American system worked better than socialist planning. So they filed our reports and continued doing what they had always done. We kept building aircraft using methods that guaranteed we would fall further behind every year. And eventually the whole system collapsed under the weight of its own contradictions. The interview was published in a small circulation journal and mostly forgotten. But it captured something important about why the Soviet Union lost the Cold War. It was not because they lacked talented engineers or dedicated workers. Petrov was brilliant, and he worked with many equally capable people. It was not because they lacked natural resources or industrial capacity. The Soviet Union had vast resources and massive factories. They lost because their economic system could not generate innovation as effectively as market capitalism. And when their leaders learned this from their own engineers and intelligence officers, they chose to ignore the information rather than acknowledge that their fundamental ideology was wrong. The Boeing visit became something of a legend among Soviet aviation engineers. Those who went told stories to colleagues who told them to the next generation of designers. The immense scale of the Everett factory, the precision of American production, the efficiency of market-driven supply chains, all of it passed into professional folklore. And every engineer who heard the stories understood the implicit message. The Soviet Union was competing against an industrial system it could not match, using methods that guaranteed failure. Some tried to work around the constraints. Individual engineers developed clever solutions to specific problems, designed aircraft that performed well despite inferior engines and systems, found ways to maximize efficiency within the rigid structures of central planning. But individual brilliance could not overcome systemic dysfunction. No matter how talented the designers, they were trapped in an industrial system that wasted resources, prioritized political goals over technical requirements, and punished innovation that threatened established hierarchies. By the mid-1980s, Soviet leadership finally began to acknowledge the problem publicly. Mikhail Gorbachev's glasnost and perestroika reforms included frank discussions of industrial inefficiency and technological gaps. Soviet newspapers published articles admitting that domestic aircraft were inferior to Western models, that production methods needed modernization, that market mechanisms might be necessary to drive improvement. But by then, it was too late. The economic problems were too severe, the political resistance too entrenched, the gap too wide to close through incremental reform. The aviation industry was not alone in falling behind Western competitors. Soviet computer technology lagged by similar margins. consumer electronics were nearly non-existent by Western standards. Automobile production used designs and methods from the 1960s. In virtually every consumer and commercial sector, whereas Soviet industry could not match Western quality, efficiency, or innovation. The pattern that Petrov observed at Boeing in 1969 repeated across the entire economy. Western observers sometimes wondered why Soviet leadership did not simply adopt market reforms earlier, why they persisted with central planning long after its failures became obvious. The answer was that acknowledging those failures would destroy the entire basis of Communist Party authority. If capitalism worked better than socialism, if market mechanisms generated more innovation than central planning, if private companies produced higher quality goods than state enterprises, then what justified Communist Party rule? What justified the restrictions on freedom, the censorship, the political repression? The party chose to maintain its authority rather than fix the economic system, gambling that they could muddle through somehow, that military strength could compensate for economic weakness, that the West would eventually experience a crisis that vindicated socialist principles. The gamble failed. The economic weakness became unsustainable, and the entire political structure collapsed when it could no longer deliver even minimal prosperity to its citizens. Petrov's 1969 report on the Boeing visit was one small piece of evidence in a massive archive that documented this failure. Soviet intelligence agencies filed thousands of similar reports over the decades of the Cold War. Reports on American computer production, semiconductor manufacturing, telecommunications technology, industrial automation, consumer goods quality, agricultural productivity. Each report told the same story with different details. The West was ahead, the gap was growing. Soviet methods were inadequate, fundamental reforms were necessary, and each report was filed, classified, and essentially ignored by leadership that could not respond effectively without admitting ideological failure. The irony, visible only in hindsight, was that the Soviet Union's intelligence collection was often excellent. They knew what the Americans were doing, understood Western capabilities, received accurate assessments from competent analysts. The problem was never lack of information. The problem was that they operated within a political and economic system that could not respond effectively to that information. Truth that contradicted party ideology was not rejected outright. It was simply processed through bureaucratic mechanisms that ensured it never influenced actual policy. This dysfunction extended beyond economics into military competition. Soviet military intelligence filed detailed reports on American weapon systems, accurately describing capabilities and identifying Soviet disadvantages. But when those reports implied that Soviet military doctrine or equipment was inferior, they were often dismissed as exaggerated or based on faulty intelligence. Political officers and party loyalists outranked professional analysts, and political loyalty was valued more highly than technical expertise. The result was a system that blinded itself to its own weaknesses, that heard warnings but could not act on them, that received truth but chose comfortable lies. And eventually, reality imposed itself with a severity that no amount of propaganda could obscure. The Berlin Wall fell. The Soviet Empire in Eastern Europe collapsed. The Soviet Union itself dissolved into 15 separate nations. And in the wreckage, researchers found archives full of intelligence reports that had accurately predicted every aspect of the failure. Petrov died in 2003, having lived long enough to see the Soviet Union's collapse and Russia's chaotic transition to market economics. He gave one final interview shortly before his death, and the interviewer asked what he thought about when he remembered that 1969 visit to Boeing. "I think about all the wasted years," Petrov said. "All the talented people working in a system that prevented them from achieving their potential. All the aircraft we could have built if we had been free to design based on engineering requirements rather than political considerations. All the reports we filed that told the truth and were ignored. I think about standing in that Boeing factory, understanding immediately that we were going to lose the Cold War, and knowing that nothing I could say or write would change anything." "Did you ever regret going on that trip?" the interviewer asked. Would it have been better not to know? Petrov shook his head firmly. No. An engineer's job is to see clearly, to understand reality regardless of whether that reality is comfortable. I saw what American industry had accomplished, and I understood what it meant. Wishing I had not seen it would be like wishing I had chosen blindness. The truth existed whether I acknowledged it or not. At least by seeing it clearly, I could do my job with understanding rather than delusion. And did that make a difference? Petrov was silent for a long moment. Perhaps not to the ultimate outcome, but it made a difference to my work, to how I mentored younger engineers, to the small decisions where I had some control. I could not fix the system, but I could at least refuse to participate in the lies. That has to count for something. It was the answer of a man who had spent his life navigating the contradiction between professional honesty and political necessity, between engineering reality and ideological fantasy. Petrov had stood in the Boeing factory in 1969 and understood immediately that the Cold War was already lost, that the Soviet system could not compete with Western industrial capitalism in the technologies that mattered for late 20th century power. He had reported that truth accurately, watched it be ignored, and continued working within the system because that was the only option available to him. His report, declassified decades later, stands as testimony to a failure that was documented thoroughly and ignored completely. The Boeing visit had been intended as a propaganda exercise, an opportunity for the Americans to demonstrate their capabilities to Soviet observers. In that narrow objective, it succeeded beyond what the Americans probably expected. The Soviet delegation saw exactly what they were meant to see, understood the implications perfectly, and reported truthfully about what it meant for Cold War competition. But the Americans probably did not anticipate how completely that truth would be ignored by Soviet leadership. They assumed, perhaps, that rational actors receiving accurate information would respond appropriately, that Soviet planners would see the evidence and adjust their methods accordingly. They did not fully understand that the Soviet system had trapped itself in an ideological framework that made learning impossible, that required maintaining comfortable fictions even when those fictions guaranteed eventual failure. The Cold War ended not with a nuclear exchange that both sides feared, but with economic exhaustion on one side and triumphant capitalism on the other. The Soviet Union collapsed because it could not feed its people, could not produce consumer goods competitive with Western products, could not generate innovation fast enough to match Western technological advancement. All of these failures were documented in intelligence reports filed over decades by observers who saw clearly what the problems were. And all of those reports, like Petrov's account of the Boeing visit, were classified and filed away by a leadership that could not afford to acknowledge the truth they contained. That, ultimately, is what Petrov meant when he said he knew the Cold War was over the moment he walked into the Everett factory. Not that fighting would cease immediately or that political tensions would disappear, but that the outcome was determined by fundamentals that no amount of military posturing could change. The Americans had built an economic system that generated wealth and innovation faster than the Soviet system could match. They had industrial capacity that dwarfed Soviet production. They had commercial aviation capabilities that made Soviet aircraft look primitive by comparison. And when Soviet engineers saw this clearly, documented it accurately, and reported it truthfully, their government filed the reports and changed nothing. Because changing something, adapting to reality, learning from what the intelligence revealed, all of that would require admitting that the fundamental ideology was wrong. And that admission was impossible within the Soviet political system. So they continued building aircraft using methods they knew were inferior, continued pretending that central planning worked better than market competition, continued ignoring reports from their own engineers that told them exactly why they were falling behind. They continued until the day the entire system collapsed and the Cold War ended, not with the bang everyone feared, but with the whimper of economic failure and political disintegration. Petrov understood this in 1969, standing in the Boeing factory watching American workers assemble 747s with efficiency and precision that Soviet factories could not approach. He filed his report knowing it would change nothing, but filing it anyway because an engineer's duty is to document reality regardless of whether anyone wants to hear it. And decades later, researchers found that report in opened archives and recognized it for what it was: evidence of a truth that was clearly seen, accurately documented, and completely ignored until it was far too late to matter.